Hi LeBois Junior High physical science students. Here's some notes on chemical bonding and formulas. You're going to want to take these notes on page 88 in your notebook. If the video goes too fast, please feel free to hit pause and fill in what you need to fill in. So the first thing that we're going to learn about is just what a chemical bond is. So it is when two or more atoms join chemically. When we talked about separating them physically or separating things chemically, when we talk about separating things chemically, it means that we're going to look at breaking that chemical bond. There are two general types of chemical bonds that we're going to talk about in our classroom, and the first one is an ionic bond, and the second one is a covalent bond. An ionic bond is between a metal and a nonmetal, and a covalent bond is between two nonmetals. A really good example of an ionic bond is sodium chloride. We know that sodium is a metal and chlorine is a nonmetal. And a really good example of a covalent bond is two nonmetals. So water is that really good example because hydrogen is a nonmetal and oxygen is also a nonmetal. So properties of chemical bonds that we're going to talk about, one is called conductivity, and it's the ability to transfer electricity or an electrical charge. We worked on this a little bit first semester, and now what we're going to talk about is if we have chemicals in solution or in water, if something is going to be able to conduct electricity. So in general, ionic substances conduct electricity better than covalent substances. So it doesn't mean that covalent substances won't conduct electricity a little bit, but ionic substances are going to conduct electricity much better. So if we were to put salt in water, for example, that would conduct a lot of electricity, whereas if we were to put sugar in water, sugar is a covalent substance because it's all nonmetals, it would not conduct electricity as well. The other property that we're going to talk about is melting point. And so melting point is just the temperature at which a solid begins to turn to a liquid. And when we talk about melting point, in general, ionic substances melt at a higher temperature than covalent substances. So it takes a little bit more energy to break an ionic bond than it does a covalent bond. So it takes longer and much hotter temperatures to be able to break that ionic bond than to break covalent bonds. A good way to think about this is if you've ever dealt with cooking with sugar, that sugar melts pretty quickly at a pretty low temperature. So just kind of have that thought process there. So what is a chemical formula? So it represents which elements and how many atoms are in that formula. So sometimes we have chemical names that actually tell us what's in the formula. Example are carbon dioxide and carbon monoxide. That di and that mono are actually prefixes which help us identify how many oxygens we have. So di means 2 and mono means 1. So here we've got carbon dioxide, so 1 carbon and 2 oxygens. Here we've got carbon monoxide, 1 carbon and 1 oxygen. And then sometimes chemical names don't tell us what's in the formula, so it's important that we're able to recognize both things so that glucose, for example, we know is C6H12O6. This is a grid that I would quickly jot down on your notebook. Maybe push pause and jot that down really quickly because we're going to do some practice together, and this practice will help you with page 89 and 90 practice that the rest of this video will go through. So water, for example, is H2O, and our subscripts, which is that little number underneath, tells us here that I have 2 hydrogens, and then this subscript is missing because it's an unspoken 1. Just like in algebra, you don't have a 1x, you just have an x. Same thing here, if you have an element there's no subscript there, you assume that it's just one of that element. So what we would write for subscript is that we would have 2 hydrogens and 1 oxygen. This will help us identify our total number of atoms. Our total number of elements here are that we have a hydrogen and an oxygen, so we have 2 elements. And our total number of atoms is that we have 2 hydrogens and 1 oxygen. Add that together and you're going to get 3 total atoms. We know that hydrogen's a nonmetal, we know that oxygen's a nonmetal, and that information helps us identify that we have a covalent bond because we have 2 nonmetals. Our next example is glucose. So glucose is C6H12O6, and these subscripts tell us I have 6 carbons, 12 hydrogens, and 6 oxygens. So I would write that down like that, just telling us, hey, I've got 6 carbons, again, 12 hydrogens, and 6 oxygens. My total number of elements is only 3 though, because carbons, hydrogens, and oxygens are the only things present in the compound. So I have 3 total elements, but I have 24 atoms. All of these are nonmetals. Carbon, hydrogen, and oxygen are all nonmetals. And so this would be a covalent bond because they're all, again, nonmetals. Our last example is potassium bromide. So we know that potassium's element symbol is K and that bromide's element symbol is Br. Bromide is when we put it into a compound, it's bromine, and when I name it, it's bromide. And we'll get more into that later. It's just wanting you to start recognizing that IDE ending. So because I don't have any subscripts here, I know that there is 1 potassium and 1 bromine. I have 2 different types of elements, right? A potassium and a bromine. I have 2 total atoms. Now here, because I have 1 metal and 1 nonmetal, I know that I have an ionic compound or an ionic bond because, again, you have a metal and a nonmetal. All right, so here we're going to turn to page 89. So this is page 89 in your notebook, and we're going to do practice. We'll do the first 2 together with you, and I'll have you do the rest of them as practice. So when we're looking here, first thing, cross out that representation column. That's a little bit easier to explain in person, so we're just going to cross that one out. So here we're just looking at counting the number of elements versus the number of atoms on this page. So when we're looking here, just carbon, the number of elements would be 1, and the number of atoms would be 1, because we're simply dealing with just an element. Water, the number of elements would be 2, because I have a hydrogen and an oxygen, and the number of atoms would be 3. And the number of atoms is 3, again, because that subscript, that number 2, which is our subscript, tells us that we have 2 hydrogens and 1 oxygen. So the next page right here, or not next page, but the next 4, please do on your own, and then we'll post the key and link it on the slides, post it on Google Classroom, do all of those things. If you can't find us, please shoot your physical science teacher an email, and we'll make sure that you have those resources. All right, so turn the page on to page 90. So now here we're going to do our next set of practice. I'll do the first 2 with you, and then you'll do the rest of them on your own, and then you're going to be able to check that, and we'll link that key as well. So calcium chloride, calcium's element symbol is Ca. Chloride is basically chlorine, and so we know that's Cl, and how we write that is CaCl2. Again, we'll teach you a little bit later why that 2 is right there. Also, reminder, cross this column out all the way down, easier explained in person. So CaCl2, so here, number of elements, I have 1 calcium and 1 chlorine present, so I have 2 elements present. My number of atoms, however, is different because I have 2 chlorines and 1 calcium. So I add all of that together and I end up getting 3 atoms. On to the next example, baking soda. Baking soda is sodium bicarbonate, and so that is NaHCO3. My number of elements, I have 1 sodium, a hydrogen, a carbon, and an oxygen. So that ends up being 4 total elements. But my number of atoms needs to be different because of that subscript 3 on the oxygen. So we end up having 6 total atoms there. On to the next 4. Next 4 or 5. Sorry, that screen's small. You have 5. Okay, so the next 5. So here, you're going to do this practice. Please make sure you cross out that column again, and we will link this onto whatever site that we're working with to get you this information so that you can go through and check. Okay, please email your teacher if you have any questions. Good job.